The topic of this video is on normal distribution and more specifically the empirical rule, which is what these notes are about. So everything that we're talking about is all based on this normal distribution curve or a bell curve. So here what you're looking at is a bell curve, right? And so that's also known as a normal distribution curve. And this is a symmetrical bell-shaped curve that describes data. So that's what we're kind of looking at in this first standard, and really all three standards that go with the statistics grouping. And so each of these lines and symbols represent a part of this, okay, or a part of this bell curve. So this first line right here in the very middle, this is the mean, okay, and it's represented by the symbol mu. So that stands for the mean. And then each of the symbols below here, that is a standard deviation. So a standard deviation is a calculation that's made. It's the same once the mathematics is done. It's the same kind of distance away from the mean. Okay, so it's standardized in terms of how much we're moving. So in this case, when you see this added once, twice, three times, this is one standard deviation away, two standard deviations, and three standard deviations away. Positively going away, meaning that's why it says plus. And then the opposite side, you can see the -1, -2, -3. So this would show you kind of the movement away from the mean, okay? So that's kind of how the bell curve is set up. An empirical rule the empirical rule is set up that along with this idea of this is the mean and the standard deviations away, we know to be true that based on this empirical rule that a percentage of the data lies between these standard deviations. That's why it is a standard deviation away. And so the first rule is that 68% lie between this first standard deviation that is added and subtracted. So the first setup is that 68% of data lies between one standard deviation all right. The second, going one farther, would be two standard deviations away, so between each two, and that's 95% of the data. So 95% of the data lies between two standard deviations. And the last is the three standard deviations, so lying between here and here, and that is 99.7% of data. So 99.7% of data lies between three standard deviations. And when we're talking about area, we are absolutely talking about, like with this first one, we are talking about kind of like all of this section. So like we're talking about area under the curve a little bit, okay? So this right here would represent 68%, which makes sense. I mean, that's a lot of the curve right there. And then when we continue it out, to the next one out, right, we would say, well, it's this plus all of this plus a little bit more. And if then we go one more, right, three standard deviations, that's there, all of this, and then all the way over here. So you can see kind of where that overlap is. That's where it kind of starts and then it grows out, okay? The other thing we can do with the empirical rule is that we can create or write down the percentages in between each section as well. And I think that's important because we could have some kind of information where we want to go between this line and this line. So if you think about between one standard deviation is 68, and remember this is all symmetrical, so it's going to be the same on both sides. So this is going to be 34, and this is going to be 34. Okay, because remember that would add up to 68. The second one, if you do the calculations, this is 13.5, and this is 13.5. And the last one, or the next one, is 2.35 and 2.35. And then the final, this very last section out here is 0.15%. 0.15%. So this is the first statistical idea that we're going to deal with or whatever. And there's going to be quite a few questions that we kind of go along with this, but it's all centered around this curve and this setup. All right. So let's take a look at an example of this. So let's say right here we've got on number 1 a normal distribution that has a mean of 35 and a standard deviation of 3. So I'm not very good at drawing bell curves, but I am really okay at drawing number lines. So I'm going to draw this number line, and I'm going to label the mean 35, and then I'm going to go out 3 lines only and to the left, and 3 lines to the right. And these represent the standard deviations away. So to go to the left, I'm going to subtract the standard deviation every time. So this would be 32, 29, and 26. And when I go to the right, I'm going to add 3 every time. So 38, 41, and 44. So now I've got my setup in terms of my standard deviations along with my mean. If you're just starting and you're a little bit nervous, you can add the percentages here as well to help you. So I'll do this on this first one just to make sure that we've got them and we're not flipping back and forth. But you can also just be looking at your bell curve for these percentages, because that's going to be kind of important. Okay, so I am ready now to go ahead and answer these questions. So the first one says, find the range of values that represent the middle 68%. Remember that 68% is 1 standard deviation away on each side. So that is going to be this section right here, 1 standard deviation. So my answer on this one would be from 32 to 38. For the next one, it says, well, what percentage of the data is greater than 38? So if I look over here, that's all of this. And so that means that I'm going to have to add these percentages up. So I have 13.5 plus 2.35 plus 0.15. And once I add those up, that would tell me the percentage is going to be greater than 38, which is 16%. Okay? For the next one, the height of 2,000 teenagers are normally distributed with a mean of 70 and a standard deviation of 2. So again, I'm going to go ahead and set up my number line. Here is my mean of 70 inches. And I'm going to do 3 lines again, 68, 66, and 64. And on this side, 72, 74, 76. Okay, so I've got my number line set up with my standard deviations. This is the difference on this question, and this is important to make note of. This one says about how many teenagers. This doesn't say what percentage anymore. So we need the percent, but then we're going to go and multiply it by the number of teenagers that were surveyed for this. So between 66 and 74. So that's 2 lines out on each side. So remember, 2 lines out. The empirical rule states that that's 95%. So in this case, I would do 95% times 2,000. And when you do that, you need to make sure that you change 95% to a decimal. So that becomes 0.95 times 2,000, which is 1,900. And then the last one, what is the probability? That's the same thing as the percent or the area. So we're all still doing the same thing. A random teen is more than 72 inches. So let's see here, more than 72 would be right here. So again, I'm going to have to add those percentages up. And this is similar like the last one. This is going to be 13.5 plus 2.35 plus 0.15, which is 16%. And this is kind of how these questions progress. So you can see that, I mean, there's lots of examples, right, where you're given the mean and you're given the standard deviation. Go ahead and draw it, and then you get to answer some questions here in terms of, you know, what percentages. Remember that if you would combine or add different sections as well. And then the other thing I wanted to kind of point out, see here if I can find one. Nope, I think that's good. So there's tons of questions out there on this, and in class I gave a ton of examples, but these are the two main types of questions, right? Where you are given the mean, the standard deviation, and asked for a percentage or an area, or you're given to calculate how many. All right. If you have any questions on this, you can always ask.